the chat box. And I am going to go through some of the features of our webinar platform. So if you haven't already, please make sure you set up your audio wizard. You should be able to hear me, which means you did. It's right here, which you can see with my little laser pointer. You can use audio when asking a question, and we will open that up if we decide it's fair, or we'll just have you type into the chat box if you have any questions. We also have some interactivity options, which you'll see right here, which is above the main room, right underneath where you'll see your name. We have this feature here is a smiley face. Gives you some options of how you're feeling, if you're enjoying it, if you think something's funny, if you want us to go slower or faster, you can let us know there. We also have the feature to raise your hand if you have something pressing you want us to address, or you have a question, or somebody asks you to raise your hand. And finally, we'll have this polling option here. Right now it looks like a check mark. It may change throughout the webinar depending on if we're asking you a multiple choice question, and then it will look like an A, and then you can do an A through E maybe option. And I'll just give you a little demonstration now. So you'll see now that looks like an A rather than a check mark. Finally, again, anytime you have any comments, questions, type it into the chat box right here, and we can hear from you. All right. Now, let's do a little test and see where everybody's from. You'll have here on your screen, it might be on the left side of your screen, this is your toolbar. The second one down is your laser pointer. And I'm going to have you all click on that, and that should give you a little star. If you hold down on it, you'll see a few other options of what your laser pointer can look like. If you wouldn't mind just putting a little laser pointer on the map telling me where you're joining us from. So I just put mine from New York. All right, looks like we have people from all over the country, which is great. So it's great to have you with us. Just one more reminder. Don't be afraid to use the text box. If you have any questions, feel free to ask. You can ask myself or either of our moderators, Howard Rosenbaum, who's our whale scientist, or Kathryn Atkins, who will be going through some of the information about how to bring that into the classroom. And if you have something really pressing, again, raise your hand. So without further ado, let's get started. This is Exploring Whales. Our first presenter is Dr. Howard Rosenbaum, who's the director of the Ocean Giants program here at the Wildlife Conservation Society that runs the 5 zoos in New York City, 4 zoos and the aquarium. And he can tell you a little bit more about himself. Take it away, Howard.
Thank you. I hope everyone can hear me just fine. It's a pleasure to be with you tonight, and I hope you'll find my presentation informative and useful for your classroom preparations. I have been working on marine mammals largely, but also marine species for the better part of 25 years, and I direct WCS's Ocean Giants program. The presentation that I'm going to give tonight is going to focus in on some of the most challenging threats that marine mammals face in our oceans today. And then I'm going to take that into some real-world context of what we're doing around the world to basically intervene and turn the tide for marine mammals. And I'll do that from using a number of different examples from our work around the world in different ocean basins, but then I'll bring it closer to home here, where I'll talk about some of our work in the Arctic, which I think will be of great interest given some of the issues around climate change that you're likely reading about in the news. And then I'll even take it even closer to home here and talk about some of our whale work that's up and coming here in New York and some cutting edge technologies that we're using. So with that, I will launch into the presentation entitled Saving Ocean Giants, Protecting Our Marine Mammals Throughout the World's Oceans. So marine mammals, including the large whales and dolphins, are some of the most charismatic, iconic animals on this planet. They inspire people. They are what we think of when we think about healthy, intact ocean ecosystems. And people connect to these marine species, whether you're looking into the eye of one of the great whales, like this gray whale here on the left side of your screen, when you have some of those experiences with those friendly whales in Baja California, or you might see a pod of, tens to hundreds to even thousands of dolphins shown on the right side of your screen swimming. They're just these amazing marvels and spectacles that you can witness today. But we're fortunate because it almost through history, these animals have great challenges and suffered great consequences from largely, when we're talking about large whales, many species being driven near to extinction from both historical and more recently commercial whaling. And you can see here, if you look on the left side of the screen, the most recent estimates, even just in the last 100 years, that almost 3 million whales were killed for commercial purposes. And dolphins and porpoises and other marine species continue to suffer from similar fates from what we call bycatch, or entanglement in fishing gear. This incidental catch of animals where these animals, in terms of their behavior, their movements, their feeding, overlap with fishing efforts, sometimes from artisanal fisheries, sometimes from large-scale international fisheries. And approximately around the world, that kills nearly 300,000 animals. So one of the hallmarks of what we do at WCS is to use cutting-edge science and field conservation science, meaning when we're out there in different parts of the world, to basically understand the needs of these magnificent animals, to find out the important conservation mechanisms, interventions, and approaches to protect them. And so here, this is some work actually that took place over, I would say, the better part of 2 decades, where I established programs to better understand humpback whales. These are southern hemisphere humpback whales. Probably many of you have seen humpback whales around the world, or maybe even just here and off the coast of, off any of the Atlantic coast or the Pacific coast. This is their southern hemisphere variety of these animals. How many people, if you could put your hands, I don't know if you can signal to me, but how many people have actually gone on a whale watch and seen whales up close and personal? Oh, wow. Okay, great. We're getting some great results here. Well, for those that have, you know exactly that kind of magical experience that I'm talking about when, one of the largest animals that's ever inhabited the planet comes launching out of the water, and here you see a mother calf leaping out of the water, breaching in sync together. But the work I was talking about shown on the right in the map, basically where we use a series of techniques, photographic identification, and remember that approach, because you're going to come back and learn a little bit more about that in the post-talk exercise with the other moderators. And we use photographic identification to identify individual animals. We use genetic techniques where we collect a little tissue sample from the animals to understand population level movements across large numbers of animals. We use satellite tagging where we put a satellite transmitter on the whale to figure out their migration routes. And over time, we can determine what are the most important breeding habitats for these animals, shown in red, along the West African, East African, and Madagascar coasts. As I said that in order from left to right, or as you're facing your screen. Basically, those efforts, by being on the boats day after day during key seasons where these animals breed, we can find out more about the population, highlighted in red where they breed. By using genetic and photographic identification, and even genetic techniques, we can figure out connectivity or movement to those important feeding grounds where they feed in those nutrient-rich waters, shown in the dark blue or purple blobs at the bottom of your screen, where these animals largely feed on Antarctic krill. So some of the work that we've done over the past 2 decades has been to, in essence, understand the recovery of these animals from these large, intense periods of commercial whaling, but then figure out what threats they face today, what their status of these populations are, and what are the approaches that we can use to better protect them. So I just wanted to give you a little bit of our, as a global perspective, where we're doing this. If you look in some of this is a global map showing WCS's portfolio and where we work and why we work. I won't go into detail on this, but I just wanted to kind of show you the work that we do. And highlighted in red are several different ocean basins where we're largely focusing on coral reef diversity and associated fisheries. And I think you can in essence tell where some of our efforts are focusing on large whales. Obviously, where you see it shown in green and with the humpback whale and our logo jumping right out of the screen. Of course, I think I don't need to say that those whales are not shown to scale or size. But we're doing this in major ocean basins, from the Arctic to the New York area, to both sides of South America, to both sides of Africa, to the northern Indian Ocean and the Bay of Bengal. So I talked about some of a major threat of what the world looked like in terms of whaling and commercial exploitation, and one that for dolphins and other whales and other marine species, turtles, sharks, other fish, that they're facing today in terms of bycatch. But there's a whole set of threats that are remarkable and of great concern in today's oceans. Those extend to both non-renewable oil and gas, non-renewable energy exploration and production, shown in the lower left quadrant. Renewable energy, in essence, these are in essence the concern here. There's a series of impacts that impact today's marine mammals and marine life that are typically associated with noise production in the oceans, making an extremely noisy environment that has been shown to actually affect these animals, both causing potential physical damage to the animals, but also disrupting important life history functions where they might use vocalizations to detect prey or to communicate with one another. Those noise impacts, where they actually call that masking, also occur from one of a chronic source of noise pollution in today's ocean, which is shipping. And in essence, the degree to which ships every day are transversing large stretches of ocean, are truly incredible. We use particular techniques to identify these ships, and in essence, you can trace these routes. It looks like, in essence, some of the busiest highways. Not in essence like as a traffic, line of ships. Some areas, yes, but you can actually find that there are ships going through major passages all around the world at any given time. And as I mentioned below, the impact of fisheries that are occurring all throughout the world's oceans. There are both direct impacts to animals, like I said, when they get entangled in fishing nets and accidentally caught, and unfortunately suffer, an early death or fate that we don't want them to have, but also where you actually may be removing prey out of their environment, the food that they depend on, at rates that causes problems for these animals. So again, just to give you an idea, as a whale conservation scientist who's been in the field for 25 years, we work and how we use these approaches. And this is how I would unpack this for when I go in to talk to my son's 5th grade class, for example. We use these cutting-edge field conservation science and techniques to better understand the needs of whales and dolphins. We then use that science, whatever that science tells us, whether it's figuring out how many whales there are, connectivity between areas, to protect those most biologically important habitats. And when we consider those habitats, we're talking about the areas where they breed, where they feed, and the areas that they use to migrate between those two. For dolphins, they don't undertake these massive migrations like the great whales, but they do have ranging patterns. So again, there are similarities. We then use our science to look at potential impacts from those threats that I just talked about, and we will devise mitigation strategies where we will look to ameliorate or lessen the threat from those activities. And there are different ways in which we can do that, either by trying to look at different timing of some of those activities, moving them out of important whale habitats. There's a range of things we can do that are typically guided by our science. And we will implement progressive policy changes that address these most important challenges. And sometimes those are laws that also have enforcement to them. It all depends on where we're working and what the goal of our efforts are. So I'm going to take a little bit of a deeper dive, pardon the pun, into the work that we do on bycatch and dolphins. These are what you're looking at on the screen here is an amazing group of species. These animals are humpback dolphins, incredible animals that we are just beginning to make some amazing discoveries from our work, and now working to protect them. So I'm going to use that as an example of a group of animals to talk about the bycatch problem. So here's the troubling reality. This is a problem that occurs as I said, in the world's oceans. It occurs both. Most people think about the large-scale industrial fisheries that are occurring, where people are seeing, where they talk about, a massive depletion of fish stocks. But some of the bycatch problems that are the greatest factors that affect the survivability of dolphins occur from medium to small-scale artisanal fisheries. And some of these animals, these populations, are literally hanging on for survival. And you can see here the range of these animals, and you can see the impacts from bycatch are direct mortality that stretches from Africa all the way to Asia. And when these animals aren't caught and killed from incidental entanglement, they're certainly impacted by it. And you can see there are marks left on these animals on the lower right-hand corner where they're shown to have notches and nicks from these nets that occur and they're getting caught. It's a signal that this is an ever-increasing problem in these habitats. So again, how we bring in our science into this conservation planning? Well, if you look at the 4 squares here showing the different dolphins, if you can believe it, these were considered 2 different species. And you can see the color corresponds to the geography where these animals are found throughout the range. All of these animals were humpback dolphins. And prior to our work, these were considered 2 different species. When we from our field work on the ground at WCS and teams that we have working in all these areas, stretching from the west coast of Africa and Gabon and Congo, all the way around the east coast of Africa to Madagascar and South Africa to the northern Indian Ocean, to the Bay of Bengal, up off the coast of Bangladesh, to parts of Asia, including China, all the way down to Malaysia and Australia. There were once recognized 2 species. When we actually collected a series of genetic information from these animals and our detailed field work, we actually were able to realize that there were 4 distinct species, one of which had never been recognized scientifically. The one in the lower right-hand corner shown in blue, the Australian humpback dolphin. So the past year I actually had the great honor and fortune to actually describe this animal scientifically and actually give it a name. But you can see here, by actually breaking this down into 4 distinct species, we could then work with governments and other partners to begin to identify that each of these groups of animals represented a distinct species. Each of them had a certain population size. Each of them had a series of threats. And we couldn't just treat them as 2 species. There were now 4 species. And each of them deserved a series of conservation plans that we would then begin to implement and work through. And so in a lot of these areas where we work, they were typically working at grassroots, very community level. So I know there's a little bit of an interesting balance and dichotomy that we have to maintain there in terms of working with some of the coolest cutting edge scientific techniques. But a lot of our work, if we're talking about local, small-scale, artisanal fisheries that are run by local fishermen, you have to get right in and talk to the communities, talk to the fishermen about the needs of these animals, and that's where WCS, a hallmark of WCS is the amazing conservation science that we do. Another amazing hallmark of WCS in our 100+ year history is the boots on the ground, flippers in the water, we say, where we're out there, we're on the ground, and we have staff that work in all of these areas. And I've spent a lot of time working in the area on the left-hand side in this what's called a transboundary national park, or a marine protected area, that straddles the country of Gabon and the Republic of Congo. And we have staff, both national staff, Bangladeshi staff, and some other expat staff that live in Bangladesh that are actually collecting these data, meeting with the fishermen. So what you see here in these slides, first you see the maps of the areas, and you can see first you can see the insets where the broader geography of these areas are, if you're not familiar with them. Then as you go into the larger map, you'll see actually a series of dots shown in the upper right-hand corner. Those are you can see those are whale, humpback dolphin sightings, other finless porpoise and Irrawaddy sightings in one area. And we go out in boats and collect those data and geo-reference where those animals are. And then you can actually see on the other side, where we're actually looking in Gabon and Congo, you can see actually areas of concentration where villages, shown in like the different colored dots along the coast, and then where there are centers of artisanal fishing efforts. So we can actually map where fishermen are going out, where they're fishing. Okay, and then if you look in the lower right-hand corner, using what's called GIS, or Geographic Information Systems, we can then begin to overlap. I mean, I'm giving you an example from the sightings and the fishing effort from 2 different countries, but you can actually see what happens when we do this, for example, in Bangladesh, in the upper left corner, in the upper right corner, when we take the species sightings and we overlay the fishing effort from that particular area, we can begin to find out where the core areas that the animals live and are using the habitat, and where the fishing effort is. And from there, we can begin to work with fishermen to, in essence, move their nets to better protect these animals if they can fish in other parts of the areas. That's one of the simple. It's not so simple, but one of the most direct strategies we can employ. So that was just an example. There are many other things that we do related to the bycatch problem, but I wanted to give you that as an example because one of the key elements here is that fishermen are going to go out and catch fish, and they need to support their livelihoods. They don't want to catch dolphins. They don't want to entangle them in nets, typically. And so we can aid them with this information to place their nets in key areas so they minimize risk and help us save those threatened dolphins. So now I'm going to bring this a little bit closer to home and focus on the whales. And again, I talked a little bit about the threats. We were talking about, and again, the entanglement from fishing gear, the noise that occurs from oil and gas exploration, sighting of wind energy. There's direct impacts that occur from shipping as well. I talked about the noise, actually, but collision and injury. And I'm going to talk about two examples where we work. One in the area known what we call Arctic Beringia, and I think I've got my arrow here, or my pointer. You can see we're working in this area right here, which is a critical choke point, the Bering Strait, where all the marine mammals that undertake the migration up into higher areas in the Arctic have to come through this very narrow choke point. It's a key area that we are working to conserve. It's also an area where, with climate change, there's a projected increase in shipping that's going to occur in this area too. So can we apply our unique, innovative solutions in terms of applying robust science to better protect marine mammals while ships come through this area? And again, I think with the Paris climate talks and everything that's happening, I think you all know, and maybe even talking about in your classes, that the Arctic, in terms of ice melt, is a very rapidly changing place. And you can see here, if I put a time series on here, you would actually see that on decadal scales, these areas were ice blocked, ice choked. We wouldn't even be having maps where ships could pass through. This is what it looked like last month. And again, here showing some of those impacts, the direct injury, the noise from ships, but also there's also something else that I didn't talk about, and which we also know all too well from the Exxon Valdez, is the threat of a major oil spill in some of these important pristine habitats. And again, being a little cheeky with the whale with the noise mufflers on its top of its head over there. These are those ship tracks that I was talking about. And again, in essence, you can see the intensity of colors, the lighter to darker colors show the intensity of traffic that occurs just along, as you can see, going up through along the Russian side, through the Bering Strait, along the Aleutian chain. I should be using my pointer here, along the Russian coast, along the Aleutian chain here, through the southern Bering Sea, and now with projected shipping. There are a number of shippers. China's largest shipper is projecting an increase of an Arctic route, oil and gas exploration up in the Arctic. This is an area, and mining as well. This is an area that is going to see a projected increase in industrial activities, including shipping. And remember, it's one of those areas where I said that majority of animals from major populations like bowhead whales, walrus congregate in these areas during certain months of the year. So, what we can do is work to provide safe passage for these animals. And I think I need to introduce you to some of this is a postdoctoral fellow, a PhD scientist that works in our program, Ricardo Antunes, and some of the key actors here, bearded seals, beluga whales, bowhead whales, and walrus that inhabit these important areas. Shown in the map is one of the proposed shipping routes that's actually, or transverse routes that the Coast Guard is putting forward. And there's a question still. This is proposed. Should traffic pass to the east or west of St. Lawrence Island? Should it come around this way? Should it come around this way? What's going to be provide direct routes, most efficient areas, prevent ships from running aground and reducing the risk of an oil spill? And we're concerned about all of those things, but also what's going to minimize which of these routes from different areas will also produce the least harm to marine mammals. And many of these animals are acoustically sensitive animals. So again, with this increase in industrial activities, there could be impacts that occur here as well. And again, you can see some of all the squares and triangles and shapes represent areas where we are putting on the ocean floor acoustic recording devices that you see as Ricardo is holding here that will 24/7 record sounds of these animals here and capture the levels of noise that are occurring into the environment. So we're going to try something. Let's see if it works. I think it would just be great for you all to hear some of these amazing sounds from these animals. So just give me a second, and we'll see if it works. This is a beluga whale, and this is what a beluga whale sounds like underwater. Hopefully you can all hear this when I click on it. Okay. Did everyone hear that? Somebody just put a hand up and tell me that they were able to hear that. Okay, great. Here's what a walrus will sound like. Let me just get this back to you here for a minute. Sorry. This is called a walrus knock. Ready? Now you're going to hear the amazing sound of a bowhead whale, the hauntingly beautiful vocalizations. Many of you probably know that humpback whales sing song, but here's what a bowhead whale sounds like. And last but not least, a bearded seal. And I'm going to let the bearded seal vocalization come on for a minute, and then I'm going to play for you what it sounds like when a ship passes through that area. Okay? So hang on one second. So here's your bearded seal. And so everyone get a little snippet of that. So that's what it sounds like when a ship of that tonnage comes through that area, in essence. So it reduces, in essence, the communication space of any of those animals that are attempting to communicate with one another. So the approaches that we're using will be to use these acoustic devices along that proposed ship traffic route to detect marine mammal sounds, to better understand the habitat use and the timing of migration. We'll also be able to measure noise. You just heard from the noise of the ship, and then we'll use that to hopefully guide safe passage. And this is what we're talking about, some of those progressive policies. So our work will inform the U.S. Coast Guard, the National Oceanic Atmospheric Administration, the International Maritime Organization, and Alaska Native communities as we work together with them to help make decisions that provide safe passage for the marine mammals and the ships in this area. And last but not least, I wanted to bring it closer to home where WCS is headquartered and where many of you have heard about in the series the work that we're doing in New York and the New York Cityscape and our work at the New York Aquarium on a variety of different species. And I know in this series there's already been discussions on urban ecology and on sharks. And so what you see here in this slide are in essence the traffic separation scheme coming in and out of New York, shown in purple, as well as other areas coming out of Providence. You can see some of it coming into Boston as well. I hope you can see my pointer as well. And interestingly here, what you also see shown in brown are lease concessions area, where there are areas that are being considered for wind farms. And in essence, again, there are issues that relate to alteration of habitat with wind farms. Again, we think renewable energy is a very good thing, but we just want it done in such a way that is done so that it impacts marine species to the least extent possible. Again, and there's also noise, both acute noise in terms of pile driving and siting these wind farms, as well as chronic noise from their operations that will occur. So just to introduce you to some of the amazing species that occur off the Atlantic seaboard, and particularly found here in New York, we're having some just amazing sightings of these charismatic species. Some right off, if you can believe, right outside the Verrazano Narrows and right outside of Coney Island, right outside the New York Aquarium in Brooklyn. And there's some even stellar photos of a humpback whale tail and the Empire State Building in the background. But you see here the humpback whales have we're seeing increasingly greater sightings. There's whale watching coming out of Brooklyn. That's an animal right here that was taken by the WCS photographer and friend and colleague Julie Mahar, right outside of Brooklyn, feeding on what we call a locally known bunker or menhaden. So there's whale watching going on during the summer months here in New York to see humpback whales. We have animals like the fin whale, the second largest animal that's ever lived on this planet, that where you can regularly see them out on the end of Long Island, off the end of Long Island, off the coast of right in that red box on the very tip of Long Island. There's whale watching centered out of Montauk, and these animals appear to have some year-round presence or almost year-round presence here in New York waters. We have an animal, the North Atlantic right whale, which I've done a lot of genetic work on in terms of looking at species differences, but also looking at genetic diversity within populations. You might have seen that from my bio. North Atlantic right whales are some of the most endangered animals on this planet. There are only 500 individuals left in the ocean basin, and some of these animals may be spending time in New York waters. And occasionally there are vocalizations that are detected on some of those acoustic recorders of the largest animal, the blue whale, the great blue whale that's ever inhabited the planet as well. And there are a few other animals here and species, but for the sake of time, I won't get into detail about that. So work that we're about to embark on and coming this month, in collaboration with our partner Woods Hole Oceanographic Institution, is to do some real-time detection of whales in and around those wind farm areas on the shipping lanes using two different acoustic techniques, where we have a real-time detection buoy and what's called a wave glider, which is an autonomous underwater vehicle. It does have a surface expression, as you can see, the person leaning over to look at that orange. So the buoy is shown on the right that says Demon on it, and the orange looking spaceship-like thing is the wave glider, which propels itself through wave action and will transverse the New York Bight or New York seascape, an area about the size of New England. And in essence, these two pieces of very sophisticated equipment will have recording and acoustic detection capabilities, where they will have underwater hydrophones or microphones to basically capture the vocalizations of whales. Those will be then sent up to the surface expression, either the buoy or the glider, which will then go up across to a satellite that we use called the Iridium Satellite System, and then be translated down to our servers at Woods Hole and WCS, where then we can actually relay that information to mariners, and within near real time we can detect species and of whales and inform in essence ship traffic, where these animals are, particularly for some of the highly critically endangered ones. We can also use it for public education and outreach as part of the New York Aquarium, and especially with the Ocean Wonders exhibit opening in the New York Aquarium rebuild in 2017. And that's a rendition you see here in the lower corner there. So there's a lot of exciting things that are happening with our work there in terms of using some really cool science. So also the work we're doing will also be based on boats, using some of these other techniques where I talked about photographic identification, tagging, etc. So I hope in that very sort of rapid walkthrough of the work we do in the Ocean Giants program, I've given you a glimpse of how we work to better understand the needs of marine mammals, the threats they face, and how we create these unique solutions for successful conservation outcomes. I thank you for your time, and I'm happy to address any questions you might have.
And everyone can feel free to type your questions into the box right in the chat over here. I'll give you guys a few minutes to type your questions in, if you have them, and then we'll move on to our next presenter, Kathryn. Howard, did you see someone asked if we have any counts on humpback whales? Brenda Eve asked, do we have any counts of humpback whales?
Yeah, working in collaboration with the whale watchers, we've actually seen an increase over the last few years. And again, this is a new industry that's kind of started up, so we're actually starting to see that the sightings have gone from 10s to 20s to 100 or so animals that you can see. We don't necessarily yet have those identified to individuals like we have in some of the other areas. So I'm specifically talking about New York. When in that earlier slide, and I think this is going to come, I think Kathryn or Kelsey are going to talk about this in the next bit of the exercise, when we actually work on photographic identification and use techniques like capture-recapture, we actually do get population estimates of those animals, and population sizes vary from a few hundred animals in certain populations to in the areas that I showed off of Africa and Madagascar to 8,000 to 10,000 animals to even larger animals that have populations that have recovered very well. I hope that and that was specifically targeted at humpback whales. I think Luciano has a question. Will the public ever be able to access the data from WCS monitoring systems in New York? Yeah, so one of the things we'll be doing actually is, as we get these systems up off the ground, as part of our mission, we want to make that very accessible in a variety of ways. One, we're hoping that there'll be some sort of platform at the reopening of the New York Aquarium in 2017. But before all that happens, we're also hoping that both on the Woods Hole and WCS websites, there'll be a way to actually engage and see that. And actually, as we launch some of our, so I'd keep an eye out for this. When we launch the Blue York campaign, which is going to announce that we're doing this when we get the buoy in the water, there'll actually be a contest where you can actually vote to name the buoy, and you can sign up to engage and get updates. So, and I think that addresses Luciano's question. So there would be an ability, I think, both from an engagement point and probably an area where there's something happen for students as well.
All right, great. Thank you so much, Howard. It looks like that's all of our questions for now. We'll open it again at the end in case anybody has something that pops up. Our next presenter, Kathryn Atkins, is our Professional Development Coordinator at the Bronx Zoo, and she's going to take you through some ways that you can bring this whale science that Howard just brought us through into your classrooms, to bring it to students, to show them that you can use whales and you can learn about whales in a number of different ways. All right, Kathryn, it's all you.
Okay. Kelsey, can you hear me okay? Can everybody hear me?
Yeah, I
get a thumbs
loud
up
and
if
clear.
you can hear me all right? Great, thank you. So, I am a coordinator of professional development for WCS, and before I was a coordinator of professional development, I was a classroom teacher. I taught middle school science here in New York City. So I want to talk a little bit about how we can bring some of this great information from Howard's presentation. Thank you so much, that was really informative. How we can bring that information into the classroom and see what we can do to engage our students with this kind of information. So first thing, I want to let you know that there are lesson plans and materials available. Kelsey has offered a link, a Google folder. The address has been shared in the chat window a couple of times. The materials that I've added there, I think, are most suitable for middle school students. You can certainly adapt them to use with other age ranges. And I think that these will cover approximately one class period, maybe 1 hour. But I've also added some extensions. So if you wanted to try and extend this to cover multiple class periods, I think there are some suggestions there for ways that you could do that. The lesson is also aligned with standards. So I wanted to hit the New York State Intermediate Science. I know that's not relevant to all of you, but those are the standards that we focus on here. And then I have some other standards that I'm sure are relevant to everybody. Common Core Literacy, 6 through 8, Common Core Math, grade 6 is covered, and also some next generation science standards for middle school are included. At the end of the presentation, I'll give you the specific standards, and the standards are also delineated more fully on the lesson plan. Again, that's available in the Google folder. And I see Kelsey just put the link up again, so it's front and center now if you want to take a look at that. There are a few lesson objectives that I'm trying to hit in this lesson plan. Hopefully students will be able to identify individual whales using the exact same science that scientists use in the field. Also, we want them to be able to list different ways that scientists can use that information from being able to identify whales to actually learn information about whale natural history. Defining population as it applies to ecology is part of the lesson plan objectives, and also using MARC recapture methodology, using actual science standards in the classroom to practice using proportional relationships. And that's where the Common Core Math comes in. If we can bring proportional relationships and make it tangible, make it something that kids can really understand and apply. Before I move on, I wanted to ask us to do a little bit of a poll, and Kelsey pointed out the poll feature up at the top. It's a little letter A, and I realized after I made this that I didn't include elementary school, which I'm really sorry about that. So how about if you are an elementary school teacher, you give me a raised hand instead of giving me a letter. But I'm curious to see what we've got here, middle school, high school, student of any age. I see we've got an elementary school teacher there. Christine, thank you, and Sue. I'll give you another second to do that. I just want to get a sense of who everybody is. Okay. And then let's move forward into why we want to ID whales and what do we think we can do with that information. So again, we've got a multiple choice here. What do you think you can learn by being able to identify individual whales? Is it about feeding behaviors? Can we pick up migration routes, reproductive histories? What are the options here? I'll give you another minute. Yes, this is a trick question. It's all of the above. We can pick out every one of these things from being able to identify individual whales. So not only can we learn about their feeding behaviors, that's that picture on the left there, we can also get a sense for their reproductive behaviors, their reproductive history, their relationships, and as Howard mentioned in his presentation, we can actually use this information from being able to identify individual whales to better understand their migratory patterns and what habitats are really important for them so that we can focus our conservation efforts. I'm making a couple of assumptions here with this lesson plan in that your students have already learned information about humpback whale natural history and that they've already been introduced to the concept of proportional relationships. I don't think this LP would necessarily be a good way to introduce these concepts, but instead it's really designed as a way to explore them more deeply and to offer your students some real-world applications of scientific practices. So let's move on at this point into an exploration of the lesson plan. We want to start out by engaging our students, and my suggestion for this is to use a famous faces flashcards. So either using photos and an electronic whiteboard or just by printing large-size photo cards, you can engage your students by showing pictures of someone that they should all know, and then ask them to shout out the identity of the individual, but by name. Nothing like getting your kids all riled up at the beginning of class, getting them to shout and jump around, and then you have to settle them down a little bit. After they've done a few of these successful identifications, insert a picture of a whale. And if a student shouts out whale, remind them that you want the name of the whale, you want the identity. And they're going to say, well, we can't do that, we don't know that. So then say, okay, I'm going to provide you with a little bit more information. This should help you, and show them a picture of a whale fluke. And if they say, which as they should, we still can't help you with that, then you can segue into saying, okay, at this point, that's what we're going to do in class today. You're going to become experts in identifying whales. and see how scientists actually use this same skill to learn information about whale natural history. So we are going to focus in this lesson plan just on humpback whales, and we're going to focus on this species specifically because humpback whale tails, or flukes, have these really great patterns and scars that are unique to each individual, just like humans have fingerprints that are unique to each person. So scientists are looking for patterns as well as the percentage of black or white on individual flukes to help categorize things. When humpback whales dive, their flukes actually come up out of the water, and that's why I wanted to include these video links. These are some really great videos from Archive that offer your students the opportunity to see this diving behavior and how the fluke can become visible. That's in video number 6 at the top. And then that video at the bottom, number 12, also offers some great shots of breaching and another behavior called tail lobbing with, again, some really good fluke views. That middle video, bubble net feeding behavior, I really love that one because even though we all know whales are big, when you're looking at them on a computer screen or you're looking at them in a classroom, you sometimes lose the sense of scale, the sense of majesty. And this bubble net feeding behavior shows humpback whales using this great technique to herd a school of fish together and then plunging up through the center of the school of fish with their mouths open to capture all of these fish, and that returns you right to that really exciting scale. So when scientists collect this fluke information, they create a catalog of identified whales, and so then when a new picture is taken, it's compared to that catalog. Now, humpback whales are found in oceans all over the world, so if you can identify that same whale in different places at different times, you can learn a lot of things about them. And there's some good questions that you can ask your students in the lesson plan to get them to lead them to think about what kind of natural history information that they can learn from viewing and understanding the variation in flukes. So tell your students then that you're going to spend some time learning to identify whales using these methods by studying patterns. First, we want to categorize flukes by the amount or percent of black or white that's found on the fluke. And I want to point out at this point in the presentation that the fluke pictures that I'm using are all from www.alaskahumpbacks.org. So this is all Pacific populations of whales, but they have really wonderful resources on this website. Very accessible. You can actually download the entire 300-page catalog of whale fluke photographs. There's also a really great website, WhaleNet, from, I believe, Wheelock University, that focuses on Atlantic populations. The pictures aren't quite as easily accessible, but it's really nice information about these two different populations. Can I put the website on the board? How about I type it here into, and I also want to point out that one of the resources that is in the Whale Resources Google folder is a list of hyperlinks to all the websites that I'm referring to. So if you're not able to grab it here, you should be able to grab it from the Whale Resources page. So in any case, this is where we're starting out, and my suggestion is you start out with just giving your students a few flukes, just 5 images, and then ask them to organize them from the percentage of most white to least white. And only starting with these 5 cards, then it's a nice introduction into the categorization used by scientists to delineate all these whale photographs. And then we're going to take it one step further, though, and use the Sketch a Fluke activity, and there's a worksheet for this in the resources, to ask them to actually, after they've categorized these, pick one of those 5 and sketch it. See if they can record as much detail as they can. And I'd like to give all of you the opportunity to think about that for a second too. If you've had a chance to print any of the materials great, you've got the sketch of fluke. If you don't, grab a piece of scrap paper. And if you don't have that, just take a look at this fluke and see if you can identify any of the individual patterns that are going to help you recognize this whale. When you think you've got it, when you're comfortable that you can identify this one, could you give me a raised hand so I know that I can move on to the next slide? Interpret tried to pick an initial one that had some good giveaways on it. So you think you've got this one, so I'm going to move on. Can you pick it out from these? I'm not sure how big this is showing up on your screen. If you can pick it out, I'd like you to put your pointer on top of the picture of the whale you just identified using its fluke patterns. Too hard to identify? Nobody's been able to put their pointer up? Oh, there's one. Yes, that's it. Exactly. This is the same sort of activity that you're going to do with your students, only they're going to have these pictures right in front of them so that it's really tangible for them. Another way you can take this a step further with your students is to play a memory game. If you have that set of 5 cards, you could print out 2 sets of them. And I'm going to attempt to do an abbreviated version of that again. And again, you're going to need your pointers here. So we'll just reveal the first one. Take a look. No match there, so we'll keep going. Turn those both back over. Hope I didn't do too fast. There's another one. And there's another one. Okay. I'm starting to see a match here, so can you put your pointer on the match for this card? Yep, there's one. That's it. Exactly. So one more. Match. Nope. But I think we've got a match here. Where's the matcher for that one? Can I get the pointers up again? The pointer is that little symbol that looks like a sun on your floating toolbar. There we go. Okay, you got it. So we'll reveal the last 2. So this is an possible extension activity, but something that would help reinforce for your students being able to identify the different whales by the patterns on their flukes. So now we're going to get into the next bit of this where we're actually saying, okay, now we've got these identifications, what can we do with this information? So whales are pretty big, 80,000 pounds and 60 feet long, but they're still pretty hard to find. Scientists can't just go out to the ocean and count all of them. So instead, scientists use their ability to identify all these individual whales, which at this point your students are starting to become experts in. And they're also using, scientists are also using their math skills to help them estimate the number of whales that exist. And they're using a technique called mark and recapture that uses proportional relationships to make these estimates. Now, because scientists are relying on photographic evidence, the pictures of the fluke, mark recapture can be conducted without actually capturing and marking whales, but just by keeping track of what whales have been sighted. So there's 4 steps involved in completing a mark recapture. You've got to capture and mark a subset of the population. Then you have to release those marked animals back into that population. You wait a period of time, and then you capture another group of animals from that same population. And the last step is recording the numbers in the second group that have a mark. So recording the numbers in the second group that you've already seen before. Now there are some possible complications, though, in doing a mark recapture study that could lead to inaccurate estimates. So some of those sources of error are things like if a marked animal had a survival disadvantage. if a mark makes an animal easier for predators to see, or if an animal is injured in the capture and release process, or if an animal migrates in and out of a population. Also, if you don't wait long enough, I alluded to that one a minute ago, you've got to wait long enough between capture rounds for the animals to disperse back into the population. And one other thing I want to point out here is that we're going to be using a really simplified version of mark recapture. So if you're interested in what some of the more complex versions and that take into account things like migration, for example, and hence, if they're more complex, they're arguably more accurate models, I have included a couple of journal articles in the Google folder that specifically talk about how mark recapture techniques are used in humpback whale populations. But moving forward, this slide is actually a screen capture of one of the handouts that I created that you can use, and it helps explain this proportional relationship that's used in mark recapture studies. So in this particular example, scientists were able to identify, just using flukes, a total of 100 whales. And at some point later in time, in that same area, they again censused, and this time a total of 50 whales were identified. But when the flukes of that group of 50 whales were compared to the flukes of the first group of whales, scientists realized that 10 of the whales appeared in both groups. So the proportional relationship is set up here, 10 is to 50 as 100 is to what? You can do some simplification of the fraction, or you can also take this a step further and introduce the concept of cross multiplication as a way to solve this. But in this particular example, you would have a total population of 500 whales that you gathered from your mark recapture. So in order to bring this mark recapture activity into your classroom, I would suggest expanding from that original 5, add 5 more cards, so now students have a population of 10 marked whales. So this is their first round. These are the whales that they identified in the first round. And I also show you a slightly different slide that has them a little more organized. So you've got these 10 individuals, and I actually created a worksheet that you can have your students spend a little time with. They've already looked at 5 of these whales in their original study where they were categorizing them from light to dark. So I've added 5 more and created a worksheet where they can just take some notes. How are they going to recognize this fluke? What patterns are they looking at? So after your students have had a chance to make these notes, then you're going to grab those 10 cards, and here's a little extra work that needs to be done. You need to embed those 10 cards into a larger population. So if you go to the alaskahumpbacks.org website and grab another 20 to 30 pictures, doesn't matter which ones, print those out, and then you mix the 10 marked individuals, the 10 that your students know, mix them in with this group of new cards. If you print 20 to 30 new cards, that should give you between 30 and 40 total cards, and theoretically you'd be able to put one card face down maybe on every student's desk so that you can really have this spread around the room. You can also do these with reduced size cards if you want to have your students work in smaller table groups. So as a full-size activity, students could then watch the teacher or other students take turns catching whales, picking up one of the fluke cards for the class to examine and decide if it's a fluke they recognize from round 1 or if it's a new fluke. And alternatively, you could just gather up the whole subset of cards and have the students work to examine the round 2 population at the same time. This is a screen capture of the data collection sheet that's provided, and I've set this up to demonstrate using cross multiplication to come up with the answers. So in this, let's make an example. If you have 10 in your original population, those are the original 10 cards that your students have worked hard to know how to identify. Let's say you've got 40 cards spread around the room, and you're going to capture 20 of those cards in round 2. So if you're doing that, then 20 is your F. And let's say of that 25 of them are whales that your students recognize. They're from the original population, so then your R would be 5. And if you do the calculations, your population value is 40. And so you had a chance there to have your students actually apply their being able to identify whale flukes to estimating the size of a population. You'll notice there are several trials here. I've got 5 listed because maybe you're not actually going to pick up 5. That was a perfect number. Maybe when you pick up that 20 cards, only 3 of them are whales that your students identify, or maybe you pick up 20 cards and 7 of them happen to be whales that your students can identify, whales from round 1. So if that happens, you're going to get a skewed estimate of the population, but if you do multiple trials, you're going to get closer to an accurate number. One possible step further, another extension you might want to consider doing, is using this map or another map. There's lots of resources available for understanding what the migration routes are. You could generate tables of data that have like longitude and latitude coordinates and dates for an individual whale, and then have your students practice mapping out that migratory route so that they can understand where this particular whale lives, what its migratory route is. So that wraps up the information that I wanted to share with you. Again, all these resources are available in the Google folder that Kelsey's been sharing. So hopefully this will be stuff that you'll be able to use in your classrooms to take all this really great information from Howard and apply it, give your students something really interesting to work on that also helps them meet some standards. If you have any questions, I'm happy to answer those for you.
Thanks so much, Kathryn. That was a great presentation, and feel free to ask any questions you have about the presentation, about how to modify it for your classroom, your students, anything you have in the chat box. And we'll give you a few minutes to think of those and type them in.
Hi, so Becky, I think one suggestion that I have to alter this, because it is a little intense, I think, to have this sort of happening all over the room. And so I think one thing that might make this more manageable is to, instead of using these cards, to use some other some other thing, something slightly smaller and a little more manageable. Like one thing that popped into my mind was those math manipulative wooden cubes. To have students do some sort of mark recapture of that population, just using colors instead, so you could have 5 marked individuals of one color and then have the rest of the population be another color. And you certainly don't have to use numbers as large as 40 cards, either, or 40 of these cubes. You could go to much smaller numbers, and then it makes the math a little less challenging. I think, Brenda, the matching game could be a lot of fun. Everybody loves memory. I love memory games.
And all those whale tail pictures are available in that Google folder, both in just individual file images and in a PowerPoint presentation that you could print out and bring into your classroom. There's the link one more time if everyone needs it. All right, I'll just give you guys, oh, okay, one more question.
So Luciano, I've got the first part of your question. There we go. So the articles that I added, they're certainly not articles that are good for middle school students or arguably high school students to read, but they're articles that are exactly this, about how scientists have actually used mark and recapture to estimate populations of humpback whales in different areas. So I think that is something important to make sure that they're aware of.
All right, well, thank you again, Kathryn, and thanks for your questions, everyone. Does anybody have any last questions for Howard? You should still be in here if you have any final questions for him or Kathryn. And if not, then we'll let you go. Have a nice evening, and we'll give you a minute to think about it.
I just wanted to say thank you. I thought I think it's great. I think bringing these are real world issues, and I think at least my own personal experiences that I've had in classrooms with students, they really respond to these types of issues, and I think the more you can interact with the WCS education materials, the better, and certainly we'll do our best to make those materials available as we get things going here in New York as and elsewhere, so those resources are available for the education department to use. Thank you.
Thanks, Howard. Oh, sorry, Kathryn, you have a couple last slides there.
I forgot. So I forgot about these. These are the standards that I mentioned for those of you that are still in the room. And these standards are also available to you on the lesson plan. So for those of you that might have left the room already, oh well. But they're on the lesson plan, so you can pick that information up there.
there's still a few people. And for those of you left, thank you for joining us. It was really great to hear from both our scientist, Howard, and our educator, Kathryn. And we have an upcoming webinar, which will be in April, with Jake LaBelle. He's going to be talking about American eels, which should be a really interesting topic. There, you can actually find them right at the Bronx Zoo. And so the Google folder and the resources are all available. You can go to our whales site, where some of you may have signed up for which you can find on this bit.ly link, or off of our wcs.org/webinars. And you can also go check out the Google folder, which I've shared a few times. And tomorrow, we're going to be sending out a thank you email with this quick survey link, which would be great if you could answer for us, as well as information about how to get your certificate that you completed this time. I just put the SurveyMonkey survey into the chat box if anybody wants to answer it now. This webinar will be archived, so if anybody wants to view it at a later date, you can maybe show the first half to your class, whatever you want to do. It will also be available. We'll send that along in the email as well. All right. Well, thank you all for joining us, and we hope to see you on the platform at the next webinar.